Okay, sir.
Okay. So, good evening, all. This is our third day, and I welcome you again in this session. So, today's first session on convolutional neural network (CNN) by Dr. Y.V. Srinivasa Murthy. Already, I introduced him yesterday, so I don't think again we need to introduce him. I request Vishnu sir to proceed.
Good evening, everyone. So yesterday we have discussed about just basic fundamentals of neural network. Today I will explain about the convolutional neural networks. I think people might are thinking that the session will start at 6:30, sir.
No, actually, in the schedule it is specifically mentioned, but once again, we will send a message on WhatsApp. Manoj sir, you just send a message.
Mm, I have already sent a message.
Okay, okay, okay.
Because
Session
in
will start.
the that means in that what schedule it is program schedule,
Uh-huh.
it is mentioned as 6:30. That's why I got doubt.
No, it was 6:30 on the first day because of the inaugural session from 6 to
Yes, yes, sir.
6:30. Uh-huh. On other day, 6 o'clock.
Uh, 1 second, sir. Just
Okay.
I'm starting.
Yeah.
Yeah, as like yesterday, today also I'll start explaining the things on the whiteboard. Then I'll connect with the PPT. Hope it is fine to everyone. Is it okay? Can you raise your hands if it is okay? Otherwise, I'll go with the PPT directly. Yeah, thank you. Yeah, fine. So is it visible to everyone? Yeah, fine. It's visible. I can see it in my other screen. So fine. Now I would like to explain the CNN part. So generally, what people will do is the applications of ML, including it contains a speech processing. Whenever speech signal is given like this, then what people will do is they will extract. One second. Yeah.
Vishnu sir.
Sir, you are not audible.
Sorry. Is it fine now?
Yeah, fine.
I'm very sorry. Yeah, fine. Sorry, I will start. So suppose whenever I'm taking the machine learning applications. So machine learning applications is nothing but it is having a variety of applications. One of the application is speech processing. So in speech processing, the signal looks like this. One cannot one cannot yeah one cannot analyze the complete signal. Generally, people what they will do is they will divide the signal into 20 to 40 milliseconds windows. So generally 1 second is nothing but it is 1000 milliseconds. If the signal is recorded at 16,000 Hz, that means 16,000 samples. 1 second is having 16,000 samples, then it will be called as 16 kilohertz sampling rate. Then 16,000 Hz, then 20 milliseconds is nothing but the window consists of 20 into 16,000 divided by 1000. That is equivalent to 320 samples. Generally, what people will do is they will take 320 samples and analyze it. So they will extract features like mel frequency, substral coefficient, pitch, ZCR, zero crossing rate, and perceptual linear, perceptual linear, what we can say, perceptual linear features, PLPs. Likewise, chroma features, people will extract. So what it will do generally from this window, we are framing a n-dimensional feature vector. For each window, there will be n-dimensional feature vector. Let us assume that the feature vector size is 56. Now, generally, whenever we are constructing the neural network, we are going to construct it with 1 to 56, and we are going to keep hidden layers. And finally, we are going to specify whether the speech signal consists of a speech signal, the class, it can be pathological study, or it can, we can say, who is the speaker of the particular speech. One can say whether the speech is having any pathological information, that means any cry information, cry analysis can be done, or whether the person is having any running nose. These kind of information can be classified, but this feature vector we have to extract, and these features are called as handcrafted features. Are manually extracted features. To extract these kind of features, generally one must know the process of understanding signal. For the purpose, he must aware about the signal processing techniques. He must know what is for fast Fourier transformation, how to convert the given signal into frequency domain using Fourier transformation or Q transformation or jet transformation. One must understand after converting it into frequency domain what kind of analysis can be done. So complete signal processing strategy is signal processing techniques must be known by the signal processing techniques must be known by the person who can extract the features from this particular thing. So that is one thing. That means an additional subject must be known by the researcher to perform some analysis on the speech signal processing. That is one thing. Second, similarly, if you take an image will be represented in the form of pixels. Any image will be represented in the form of pixels, where a single pixel may contain the information from 0 to 127, sorry, 0 to 255. In case if it is a gray pixel, the same pixel, that means any pixel may contain the information in the form of 0 to 255, comma, 0 to 255, comma, 0 to 255. The first part is for red, the second part is for green, the third part is for blue. That means, fine. Now here also what the researcher will do, he will apply some image processing techniques here. Then what he will do, again he will represent a feature vector of n dimensions. Let us assume that the number of features extracted is 49, 0 to 49. Total 50 features are there. So for the first image, he will extract 49 features. For the second image, he will extract 49 features. Or for a small window, he will extract 49 features. Then he will move, he will extract 49 features. Then he will move, he will extract 49 features. Based on that one, then they will perform the classification task, passing it to different classifiers. Here also, features are extracted manually. We have different types of classifiers, but features were extracting manually. So these are also called as handcrafted features. So what did we understand is, to perform the classification with the neural network, one must have an M by N matrix. As I specified yesterday, one must have an M by N matrix where it is having M samples and some x1 to xn minus 1 independent variables, and xn is dependent variable, or we can call it as y. This kind of representation must be brought to perform the classification. But till now, what people used to do before the evaluation of convolutional neural networks, people used to extract these features manually. Now the question is, can we automate it? Yes. The solution is convolution. The solution is convolution. Is it clear to everyone what is the necessity of convolution process? Now, CNN is nothing but convolutional neural network, where the part 1, phase 1 will be convolution, and phase 2 will be neural network. Now, if an image is given, first of all, it will given to the convolution. It will extract the feature vector. The feature vector will be given to the neural network, and finally, we will perform the classification. So we shall see how features can be extracted from a given image. I have prepared a beautiful PPT for this process. I'll try to explain. How. So hope it is visible to everyone. Yeah, it's visible. Fine. So the presentation outline is what is deep learning, theoretical explanation that I had given already, convolution process, max pooling, striding and padding, one application that is digit recognition. So we shall see some case studies over here. What are the things that we can do? Conclusion and research scope. So generally we have different types of fields. So one is image and second one is text and third one is speech. These are the three important fields in the uh, computer science domain apart from the networks. Again, networks will be represented in the form of graph only. So fine. Anyways, image, text, and speech. So the whenever we are performing the image recognition process, one must know what is pixel. So pixel will be converted to edges. So that is the combination of pixels. We can say it in edges. Then text on, motif, part of the image, and object, part of the object and object. So this is a image parts. Whenever we are talking about text processing, the text processing will be starting with the fundamental part of the text processing is character. The combination of characters form a word. Then it will belong to word group. What kind of word it is? Suppose if I'm talking positive word or negative word, it can be word group. Clause, then forming a sentence. Collection of sentences will form a story. This is about the text processing. The applications include text summarization, word prediction, and all those things. Then the next important area is speech. For speech, the fundamental part of the speech processing is sample. The collection of samples can be converted into frequency called as spectral band. Okay, the spectral band will be converted to sound. Anything. Sound will be converted to phone. It can be any phone. A, or any sound, the fundamental sound, forming a proper phoneme out of it. The collection of phonemes will form a word. Again, the words can be given into the text processing. These are the major research fields, and everything will be converted into this particular format. So apart from the networks, I said networks and wireless sensor networks. Fine. How image will be seen by the human is nothing but one can say that it is an ape. So one can see eyes, it is having nose and it is having mouth, so hair, so on proper shape. That this shape many times you might have seen, and it will be called as ape. But how system will see that image, in the sense, if you are given any image, system will see the image in the form of pixel values. The pixel values are from 0 to 255, as I said. In case if it is a gray image, if it is a color image, each pixel will be represented in the form of 3D. That means RGB values. See, suppose if 9 is there, 9 can be represented in the form of pixels like this. So the 167, if there is a complete white, it is 252, and 255 pure white, 255 is here. And similarly, if black is the zeros, 0 represents black and 255 represents white. So finally, how computer will see your image, in the sense, in the form of M by N matrix. Each part will be considered as pixels. The combination of pixels will lead to the image. The resolution of the image will be depending on the number of pixels considered here. Similarly, in the speech processing, the resolution of the signal will be depending on the number of samples considered for 1 second. So human view versus machine view. S can be seen by human like this, width and height, and it will be converted in the form of pixels, and it's a two-dimensional matrix, or it's an array representation of the image. In case of color image, once if we consider it as a color image, then how it looks like, in the sense, if you have taken an image of size 260 by 194, then actually color image will be represented in the form of 260 by 194 by 3, where each pixel will be represented with 3 values, that is R, G, B. If you take the leftmost this particular pixel, then The RGB values of this particular pixel are 8, 15, and 14. So likewise, it will be each pixel will be having 3 values. So in case of black and white, the image size is width by height, that is W by H. But in case of color image, the image size will be width by height by 3. So the same repetition, 8 will be seen by the human being like this, but 8 will be seen by the machine like this. One can see the proper information has been provided. So how it has been represented exactly. Where pure white is represented E 255 and pure black is 0. 7 is nothing but it is not exactly 0, almost equivalent to 0. Fine. This is the representation of 8 in the form of uh, matrix. Then similarly, how the puppy looks like, it's very cute, right? Fine. So this puppy is a color image, it will be represented in the form of RGB. So the leftmost value is 141, 35, and 31. Likewise, if an image is of size 128 by 120, to represent it in the form of RGB, we need 128 by 128 by 3. Fine. Generally, if you want to convert an RGB image into gray image, everyone must know. So they will take the mean of these 3 things. That means 141 plus 35 plus 31 divided by 3, that is equivalent to 69. Likewise, we'll find the mean of these 3 values that forms a gray image for the given RGB image. Now the next question is how convolution will be performed. So let me copy this. Yeah. Send a copy. Because I can write also. That's why I copied it too. Yeah, fine. Let me share the screen so that one can understand in detail. Fine. Yeah, all these things are discussed. Yeah, fine. So 141 plus 35 plus 31 divided by 3 will give the value of 69. So one can see likewise, similarly 142 plus 36 plus 32 divided by 3 will give the value of 70. Likewise, the color image can be converted into gray image. Once it is converted into gray image, we can perform operations, although we can perform the operations on color image as well. Fine, anyways. The next process that you have to understand is how convolution can be done.
By
How
applying
convolutional?
filters, sir?
Yeah, but how we can apply filters? There are different types of filters available. But how convolution operation will work? What is meant by convolution is my question.
So on a particular image, we will select one particular part from an image, and on
Yeah,
that image, filtering
I
process
select.
will be done.
I have selected 3 by 3 window.
Okay,
Fine,
sir. Okay.
and it is my convolution filter of size 3 by 3. Okay, so then how convolution will happen in the sense 152 into minus 1 plus 68 into 0 plus 125 into 1, okay, plus then 78 into minus 1 plus 85 into 0 plus 89 into 1 plus 214 into minus 1 plus 56 into 0 plus 200 into 1, that is equivalent to 85. That will be replaced in the center portion of the image. So you'll get some value, sorry, not 85. You'll get some value that will be replaced in the center portion of the image. The result will be. So fine. This is the process, basic process of convolution. Please remember it. Yeah. As I specified that the convolution neural network will be having two portions. One is convolution process and second part is neural network, fully connected layer. And in between, we are extracting the features automatically. These features are automatically extracted features. Whatever the vertical representation of the features that you can see, these are automatically extracted features. And this is the input. First input will be given to the convolution part, then we'll get the features, then that will be given to the neural network part. So this is phase 1 and this is phase 2. Yesterday we had discussed about the phase 2 completely. Am I right? Now we are going to discuss about the phase 1. So now how, suppose if this input image is given of size n by n, how convolution operation will be performed? Ma'am, tell me, ma'am. Aparna, ma'am. Aparna, ma'am. Ma'am, you have raised the hand. If it is by mistake, I'll continue. Yeah, fine. Leave it. So fine. Phase 1, we are going to learn about it. So for the phase 1, the input must be an image of size n by n. So how convolution will be done in the sense? An image will be divided into windows in such a way like this. Yeah. Can you see? These are the windows of one step. When how people's stride will be identified whenever they are walking. Whenever they are walking, their stride will be identified based on their walking speed. That means how they are walking. Am I right or not? How they are moving the leg. The difference between the first leg and second leg will be considered as stride length. Am I right or not? You can see whenever you are walking, if you are having a smartwatch, there are different types of parameters of which one is stride. Stride can be 105 centimeters. It will come like that. You can observe it if you want. That means how what is the suppose if it is if people are runners stride length will be some 105 to 110 centimeters. If they are sprint runners, their stride will be more. So similarly, the window whether we are moving by 1 step or 2 step will be depending will be the stride in this case. Okay. So then, as I said, that the window will be getting multiplied with the filter of size k by k or f by f. Okay. Then you will get a new size. If the input is 6 by 6, if you perform the filtering operations with stride length 1, then you will get 4 by 4. How I'll explain again. The same thing, if you perform the operations with stride equal to 2, then if you apply 3 by 3, then the output window will be 2 by 2. So these things I would like to explain in detail. So finally, what you have to understand is convolution is nothing but take a filter and perform the convolution, then apply max pooling, then the image size will be reduced, then again perform the convolution and apply max pooling, convolution, apply max pooling. Finally, you will get a horizontal vector and represent the horizontal vector in the form of vertical formation. Simple. This is what we have to do here. Yeah, I'll come back here again. I would like to explain about the convolution process now. Let us assume that I had taken a window of size 3 by 3, since the filter size is 3 by 3. The input image is of size 6 by 6. And I had taken two filters here, filter 1 and filter 2. Filter 1 size is 3 by 3, filter 2 size is 3 by 3. Now, the first window, if I apply on this particular filter, 1 into 1, that is 1, 1 into 1, 1, 1 into 1, 1, that is, this value gets replaced by 3. That means I'm going to get a new window. The first part of that window is 3. Then what I will do? I will move my window by 1. Then 1 into minus 1, 1 into minus 1, that is minus 2, 1 into 1, minus 2 minus 1, minus 2 plus 1 is minus 1. Then again I will move my window by 1. 1 into minus 1, 1 into minus 1, 1 into minus 1, that is minus 3.
Excuse me, sir.
Yeah, ma'am.
Sir, my doubt is when we are applying filter on a particular image, for example, if we consider a gray filter or else some filters will be there. No, sir. Just we are applying
Edge filters, stubble filters, any filter. Yeah, yeah. Tell me, ma'am.
Then we used to apply the filter on a specific area of the image. No, sir.
Yes, ma'am.
Then how it is going to stride on that particular specific image of the image with the help of the filter?
Now consider this particular part. Let us assume that whether I can copy it or not, I don't know. Oh, sorry, I could not copy. Now imagine this particular filter on the first window, ma'am.
Okay, sir. Okay.
This is my first window. You will get one value, right? If you perform the convolution.
Yes,
that
sir.
is 3.
Yes.
That is 3.
Okay, sir.
Then the red part is there, right? That is my second window. That means I'm moving stride equal to 1.
Okay, sir.
The red part equal to the same filter I have put it on the red part.
Okay.
I got the value of minus 1.
Okay, sir.
Then I moved the then my stride equal to 1. Then I have moved. I consider the brown window.
Okay.
I have placed the same filter on that brown window.
Okay, sir.
And I got minus 3.
Okay.
Consider
Okay, sir.
consider the green part is my fourth window.
Okay, sir.
Got it?
Yes,
Green
sir.
part is nothing but 1 into minus 1, that is minus 1. 1 into 1, minus 1 plus 1 is 0. 1 into minus 1. So it is minus 1.
Okay, sir.
So that means I got 4 columns in the first row. Then what I will do is I'll go down. This is my next window. Got it, ma'am?
Yes, sir.
Yeah, ma'am. So likewise, we'll get some value here, some I'll take some black, some x here. Then I'll consider this part as next window. Then I'll get y, some values over here. Then the last window is this particular portion is the last window.
So these filters will move entire image, no, sir? After
Entire
selecting.
image, ma'am.
Okay, sir.
It will move on entire image. Then
Thank you,
Z. You will get Z. So the size of the image will be 4 by 4. Now the relation is 6 minus 3 plus stride value 1 divided by 6 minus 3 plus 1 is the new image size. That means one has to understand that if my input image is of size n by n, if I apply a filter f by f on this particular n by n, the resultant image will be n by n minus f plus 1 divided by 2 s n minus f plus 1 by s into n minus f plus 1 by s. This is the fixed formula. That means if the input image is 6 by 6 and my filter is 3 by 3, that is equivalent to 6 minus 3 plus 1 divided by stride value is 1 into 6 minus 3 plus 1 divided by stride value is 1. That means the resultant image will be of size 4 by 4. One should have this much of internal understanding of convolution process. What will be the input image, and if you apply filter, what will be the output image? Output image size also must be known. I'll have some water and come. Just 1 minute. Yeah, fine. This I have represented in the form of yeah. Some slideshow has been made for this. Yeah, is it visible?
No, sir.
Now is it visible? Check it please once. Blank page is there?
Yeah, visible.
Yeah, fine. Now an image 6 by 6, a filter, 2 filters 3 by 3. Now first window has been taken, that is 1000100001. We have applied dot product and summation on the filter. Then we got 3. Then that is stride equal to 1. So it will move to rightwards, towards right. The second window of 3 by 3 has been taken. Then we apply filter -1. Then again, if it is stride equal to 2, we'll leave one space and we'll go to the next part. So I want to explain about stride equal to 2 also. If we are taking stride equal to 2, then equal to 3 minus 3. So I will finish all the process with stride equal to 1. Just observe it carefully. First window has been taken, applied field, perform the dot multiplication and summation, 3 value we got. The window, we have moved one stride equal to 1 stride towards right side. So then it is -1. So then the next case it is -3. The next case it is -1. Fine. So now we are going to apply it down towards downside. Then it is -3. Likewise, we have applied to all the things. The last window, since it is 1 -1, 1 -1, that is -1. So 6 by 6 image is taken and 3 by 3 filter has been applied. We got 4 by 4 window. So similarly, if you apply and filter 2, then we'll get -1, -1, -1, -1, -1, and the last window is 3. So that means if I had taken 6 by 6 image, 2 filters of size 3 by 3, that means 3 by 3 by 2, then the outcome will be 4 by 4 by 2. Is it clear, ma'am? Siri, ma'am.
Yes, sir.
It's proper, right?
Yes, sir. Yes, sir.
Yeah. So this is the representation that I had. Now you can take, so the same thing that I mentioned here. If I had taken an image of size 6 by 6 as input image and filter 3 by 3 by 2, then the outcome will be 4 by 4 by 2. Now, can anyone tell me if I had taken image of size 64 by 64 and my filter size is 3 by 3 by 32, what is the output? My input image size is 64 by 64 pixels. My filter size is 3 by 3 by 32. What is the outcome? Can anyone guess? (62 by 62 by 32). Understanding? 62 by 62 by 32 we'll get. Yeah, so fine. In case of color image, we'll be having the input image the input will be by 3, 6 by 6 by 3. I will apply 3 by 3 by 2 filters. Again, I'll get 4 by 4 by 2 only. So this is the one. So now what we have understood, the input image has been given. We have applied some filters and we applied convolution. Then we got the output. Now this output can be represented. Suppose 6 by 6 directly, if we represent, it will be 36. But 4 by 4 will be around 16 plus 16, that is 32. That means we reduced it to a little bit. So you can represent all these values in a vertical fashion. Then it will be feature vector. If you don't want to convert it into apply filters, directly you can give an image as input to the neural network. It will form a deep neural network. Sometimes it may not perform well. If you apply convolution, definitely convolution has given the better results depending based on the researchers quoted. Fine. So now the next part of the image. So what I told, the input image will be given. We'll perform the convolution process. Then we'll get some output. Then we have to perform the max pooling. What is the necessity of performing the max pooling here? The necessity of performing the max pooling is, suppose I will explain why pooling is nothing but, suppose if image is like this, if first sees of the bird, it is looking like that. What people are telling that even if you have taken the subsamples of the particular image, there won't be any difference in viewing the image from human perspective as well as machine perspective. That's why what people have thought is, instead of using the complete samples, consider the subsamples of the pixels. So that is what people have thought. How max pooling will be performed? Now it's my next question. Yeah, after applying with filter 1, I got a 3 minus 1 minus 3 minus 1 minus 3 1 0 minus 3 minus 3 minus 3 0 1 3 minus 2 minus 2 minus 1. Now if I apply max pooling, yeah, let it be filter 2. If I apply, then this is the outcome that I got: minus 1 minus 1 minus 1 minus 1 minus 1 minus 1 minus 2 minus 1. Likewise, last row is minus 1 0 minus 4 3. So I'm taking a 2 by 2 window for performing the max pooling. Max pooling is nothing but consider the maximum value from that particular window only. That's it, simple.
Just the shrinking of the image, no, sir?
Yes, only considering few samples of the image, subsamples of the image. Dominant pixel values. This is 3. The maximum of the next window is 0. The maximum of the next window is 3. The maximum of the last window is 1. That means 4 by 4 image has been changed to 2 by 2 image. So we reduced half of the size. Similarly, minus 1, 1, 0, and 3. So this is about max pooling. So fine. Now 6 by 6 image has been given to the convolution process. We got 4 by 4 image. That 4 by 4 has been given to the max pooling. We got 2 by 2 by 2. That means 2 sets of 2 by 2 images we got. See, this way we are trying to reducing the size of the image. So this is one layer of convolution process, one phase of convolution process, including one convolution and max pooling. Again, give it to the convolution and max pooling, we'll get another subset, a new image we will get. The new image will be flattened. Flattened is nothing but all the pixel values will be kept in the order, in the one vertical order, vertical representation. So then the flattened image will be given as an input to the neural network. Now this neural network may have any number of hidden layers. So finally, if it is an animal classification, cat, dog, fox, and tiger, elephant. If you want to classify it into animals, you can classify it into animals. If you want to classify into digits, we can classify into digits. So this is the complete convolution process. How flattening will be done in the sense? 3, 0, 1, 3 will be the first flatten, and the next thing is filtered to minus 1, 1, 0, 3. So converting it into flatten. Now imagine this is the input for the neural network. Is it making sense? Is it fine to everyone? How convolution operation will work? So I think the fundamental convolution process is fine, right? Now take the input image is 28 by 1. The number of filters considered are 25 and filter size is 3 by 3. Can anyone tell me what is the output image? Can anyone tell me what is the output of this image if you perform the convolution operation? 28 minus 3 plus 1 by 28 minus 3 plus 1. So 28 minus 3 plus 1 is nothing but it is 25 by 25 by 25, because 25 filters are applied here. So fine. Now I'll yeah. Yeah, sorry, 28 minus 3 plus 1 is 26 by 26 by 25. That means there are 25 filters. Then applying max pooling, it will be 25 by 13 by 13. That means 26 by 26 image has been converted into 13 by 13. Then if you apply filter 50 filters, if you apply of size 3 by 3, then 13 minus 3 plus 1. 13 minus 3 plus 1 is 11. 50 by 11 by 11. Then apply max pooling. It will be 50 by 5 by 5. So that means 28 by 28 by 1 image has been converted into 50 by 5 by 5. That means 50 by 5. 50 into 5 is nothing but how much it is? 250. Yeah, 250 into 5. 250 into 5 is nothing but 1250. Am I correct? So that means the number of inputs for the neural network will be 1250. Is it fine? Sir, is it audible from my side?
Yes, sir. Yes, sir. Audible.
Yeah, fine. So this is what you have to understand whenever convolutional neural network has to be built. Shall we go with hands-on? One two five zero as I specified. That 1250 will be connected to the input of the neural network. The input in between will be having many number of hidden layers. Is it making sense? And the activation function that I used here is ReLU always. So now I will share one document with all of you. So along with the document I'll share it with Banay sir. He will put it in the group. We shall see the hands-on directly. That code was written by me. Then quickly I'll explain one application with respect to that medical image processing. So BAT. Consider this, not this one. Yeah, CNN code, the data set. One second, I'll share it with Banay sir. You people can experiment parallel with me. Fine. So Banay sir, can you keep that file in the group?
Yes, sir.
Hope the screen got shared to everyone. Yeah, fine. Documents, Python experiments. Let it be new folder. It can be YBIT, ACT, ATAL. So just I'm writing the new file. So same code I'm executing here. Whatever I have shown to you. So to perform these operations, we need CV2. Since we are performing the operations with images, CV2 is the open source package that is available to display the image, to view the image, to know the size of the image and all those things. Then to perform mathematical operations, we need NumPy. NumPy is NP. Yeah, fine, right? Yeah. Then we need pandas. Anyways, pandas is not required in this case. Anyways, we have to convert it into data. Pandas as PD. Then import matplotlib pyplot as PLT. That means to plot the images and all those things. Since we are working with TensorFlow, so we are working with the data set. So anyways, I'll execute here. We are working with the data set called as MNIST. So from TensorFlow dot keras dot datasets import MNIST. That is MNIST is a digit recognition data set. You can see if you want. So actually we had to download it from the Kaggle. Since to download it from Kaggle, again I had to share the Kaggle link and all those things. So directly I'm giving the MNIST here. So everyone can execute directly. So this MNIST will be having the train data as well as test data. So x underscore train, comma x underscore y underscore train class labels, and similarly x underscore test, comma y underscore test is equivalent to MNIST dot load data. That means the data gets loaded into x train, y train, and x test and y test. So it will be having totally the total number of images. It is 16,000. 70,000 images will be there. Out of that, 60,000 images have been considered for training. Each image is of size 28 by 28. So s set x underscore train dot shape. S set x underscore test dot shape. S set y underscore train dot shape. S set y underscore test dot shape. If you print as test L0, it is test. If you print this x underscore train dot shape, it will print 60,000 images. Each image is of size 28 by 28. The next part of the code that I had done it for printing some 5 random images. So to print some random images, I had taken the function called as define plot underscore data of x underscore train. From the train images, I'm plotting some 5 random images. Then random IDs I had generated around 16 random IDs, 4 by 4. I want to generate now 9 random ID is equivalent to np dot random dot int random int np dot randint random dot randint np dot random dot randint. Randint is a function to generate the random numbers. It is of subpackage of random, where random is a subpackage of numpy package. Randint of 1 comma x underscore train dot shape of 0. That means x underscore train dot shape of 0 means it will give only 60,000. Shape of 1 is nothing but 28. So likewise, so fine, 60,000. That means the random number integers will be generated from 1 to 60,000. Such kind of random numbers I'm generating 9. Then figure comma, so since there are 9 images, figure comma axs is equivalent to plt dot subplots 3 by 3. Each figure size is of size 7 comma 7. So then for I comma ax in range in enumerate of ax is dot flat, that means whatever the total number of 9 images. Axis dot plot is nothing but this axis dot flat is nothing but 3 by 3, that is 9. If you print axis dot plot, you will understand. So that means 3 by 3 will be converted into 9. Okay. Ax dot im show of x underscore train of I comma all pixels. Then plt dot show. This is my function. Okay. So fine. X I comma, so this is sorry, I comma colon comma colon. Now plot data of x underscore train. It is plotting 3 by 3 images, some randomly 9 images. So all the time it may not come same. 50419233131. 504192131. Okay, I think it is yeah. Randomly it is selecting those images only. 504192131. So can I proceed hands-on like this, or should I explain the code directly? What do you want?
Proceed, sir.
Yes. Now we have to give it to the neural network, that means convolutional neural network. So the very easy to this process is very easy to understand if you understand the concept of CNN. So import the required packages are import TensorFlow as TF. Then from TensorFlow, I'm importing Keras. From TensorFlow.keras, dot models, import model class. Then from TensorFlow dot keras dot layers, sorry, directly Keras, import layers. How many hidden layers that you want to keep? Yeah, this is fine. These are the sufficient things. Okay. So the total number of classes are 10 here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of classes are equivalent to 10. The input shape is equivalent to x underscore shape of, sorry, x underscore train shape, x underscore train dot shape of 1, x underscore train dot shape of 2, 1. That means 28 by 28 by 1. 1 stands for it is a gray image. If it is 3, then it is a color image. If it is 3, then it is a color image. If it is 1, then it is a gray image. So this is my input shape. You can see input shape is equivalent to 28 by 28 by 1. It's a tuple with the 3 values. Okay. Then I'm building my model. I'm defining build model function. with input shape, that is my input image shape will be 28 by 28 by 1, and number of classes, the number of classes are equivalent to 10. Okay, so I'm passing it to the input of the convolution process. The first step, this is image, I have to give it to the first convolution process. You have to imagine that in your mind. Okay, so I'm specifying my input shape. Layers dot input of shape is equivalent to input shape, comma, name is equivalent to input layer, or otherwise you can give input it is. You can give it is an input. Fine. Now, so this will be given to the first convolution. That means con1, I can see. Con1 is equal. So this layers dot input, it will be stored into the input data. Let us assume that. Or input, you can give it as an input also. Anything is fine. Con1, my convolution 1 will be layers dot convolution 2D is a function. I'm using 32 filters. The size of filter will be 3 by 3. The size of the filter will be 3 by 3. The activation function that I'm using is relu. Okay. This, the name for this particular one is con1. Okay. That name I'm giving is con1. And this will be applied on the input. Input is a keyword, I think. You can give input data. This is my con1. So till here we'll print model summary. We shall see how it looks like. So M is equivalent to build model, or model is equivalent to build model of input shape, comma number of classes. You can give 10 also if you want. Model dot summary. Yeah, fine, sorry. Okay, completely. Yeah. This con1 we can give it to the dense layer. Anyways, we shall design the complete model and then we can see. Then what we can do, it will perform the convolution as well as pooling. So both convolution and pooling will be done here at this stage. Then the second stage, con2 is equivalent to layers dot con2d. This time I'm taking 16 filters. Kernel size is equivalent to 3 by 3. Activation is equivalent to relu. Name is equivalent to con2. For this, the input is con1 is the input. For this, the input is con1. Now, two convolution operations have been done here. This convolution process includes the max pooling. You need not write a separate function for the max pooling here. It includes max pooling. This is two convolution process is done. Then we have to specify the max pooling also. Sorry, max pooling also we have to do. Pool 1 is equivalent to layers dot max pooling 2D. We are performing this operation on 2D function. Pool size is equivalent to 2 by 2. That means 2 by 2 window has been considered. Name equal to max pool 1. So this I'm giving it to the max pool 1. Fine. Now pool 2 is equivalent to layers dot max pooling 2d of pool size is equivalent to 2 comma 2, name equal to max pool 2. For this con1 is input, for this con2 is input. Yes. Yeah. Now convolution is done, max pooling is done, convolution is done, max pooling is done. Convolution part is over. Now we have to flatten that layers. So neuron input, NN input is layers dot flatten. That means the flatten layer, name equal to flatten of pool 2. Whatever the output that we got at pool 2 will be flattened here. Now we can create a dense layer with 128 hidden layers or 64 hidden layers. That is up to your wish. Okay. NN is equivalent to neural network is equivalent to layers dot dense of 64 hidden layers, where activation function for each hidden layer will be ReLU, rectified linear unit, and name is equivalent to dense one otherwise. So it will be given as NN underscore input. That means for the input of the, so we are passing this input to the neural network. So now neural network will perform its operations. Finally, my model is equivalent to model with. So then we have to apply the softmax also. So output data is equivalent to, then after completion of all the layers, then finally we are going to give the softmax layer. That softmax layer is the combination of inputs and outputs. So inputs is equivalent to input data and outputs is equivalent to NN. Sorry, output data. This is for model actually. This is model. For model we are passing inputs equal to input data and outputs is equivalent to output data. Yeah. And name is equivalent to CNN 2D. So this is my model. Now my output data is equivalent to layers dot dense of number of classes. How many number of classes you want to keep it in the output layer? So activation is equivalent to softmax, that is a sigmoid function. And it will be for NN. This is my model. Max pool 1 is not defined. Max pool 1 is not defined. Where it is here. Somewhere max pool 1 had come. Sorry, it is pool 1. What is the next part? Dense. Dense is a function D and C. Fine, right? Yeah. Still, what is the error? Max pool 1 is used 2 times. Now, I don't want to explain with this much of big image. The input shape will be 6 by 6 by 1. Okay. The number of filters will be 2. Now understand this part. That is fine. What is the input? As per my explanation, what is the input? 6 by 6 by 6 by 6 image. After performing the convolution operation, what is the image size? 4 by 4 by 2 filters. Then after applying the max pooling, 2 by 2 by 2. If you convert 2 by 2 by 2 into flatten, 8. That is given into 64 layers of dense neural network. So that means totally 576 parameters are here. That means 8 by 64, that is equivalent to 576. That 64 by 10 is equivalent to, sorry, 8 by 64 is 566, right? No, not 566. 8 by 64 is 512. 512 plus 64 bias values, that is 576. 64 by 10 is 640 plus 10 bias values, that is 650. The neural network is containing all these parameters. Got it? The input image 6 by 636 is initially converted into 20. Then further it is converted into 8. And it is given to the 64 one. That means only one hidden layer is there with the 64 neurons. So 8 by 64, that is 512. For each neuron, for each hidden neuron, we will be having one bias value based on the yesterday's explanation. 8 by 64, that is 512 plus 64, that is 576 parameters. Now that 64 hidden neuron is connected to the 10 classes. So 64 by 10, that is 640, and 10 bias values, 650. So these are the complete parameters. The total number of parameters is equivalent to 1246. Any confusion in this? Is it making sense? Is it making sense or not? Someone can respond.
Good evening, sir.
Yeah, ma'am.
My question is that in the starting you are using the convolution layer 1, then you
Yes,
are
yes.
using max pooling, and
Yes.
then we are designing the NN input, we are designing the neural network.
Yes, yes.
I just want to ask that in the output data, how many values I will get? Just you are saying that in the
One of the
starting.
10 classes. One of the 10 classes will be activated, and remaining 9 classes will be. That means probability values will get for all the 10 classes.
Okay, so according to the input value, it will give me the value whether it will belong to class
Yeah,
1,
if the
2,
input
3.
is number 1,
Okay.
then it class 1 may be getting the high priority, and the remaining classes may be getting the low priority.
Okay, sir.
It's a one out of n classification problem.
Okay, so suppose I have an image in which we have only 2 classes. So in the num class, I have to write only 2.
Only 2.
Okay, and one question. Second question is that suppose we have an image, and according to the convolution and pool layer, we are designing our model.
Yes,
So
yes.
it will automatically detect that it belong to which class. So, but it will not tell us na, ki which features they are extracting or what are the important features in that particular
That
image.
depends on the number of filters that you are taking, ma'am. It will be
Okay.
filter values are random, so it's a trial and error method. It's a black box completely. I want to
Okay.
open black box up to some extent. That means whatever the possible. That randomized cannot be changed. So it will be depending on number of iterations that you are running your algorithm, number of hidden neurons that you are using. You can add one more hidden layer here.
Okay. So suppose I want to know how which features are prominent for that we have. Do we have any technique?
No, no, ma'am. That because features are getting automatically extracted and through randomization.
Okay. So I cannot get ki which features they are using or which pixel value they are using. It is
No, no,
using.
no, no.
Oh, okay. Oh, okay, sir.
Now, but after flattening this one, these features you can use it use it for our other machine learning models also.
Okay.
Or
Okay.
you can
Thank you, sir.
fuse with, or you can fuse the manually extracted features with these features also.
Yeah, actually, in the manual extracted feature, we can easily find out that which feature we are using.
Yeah,
Like
those
in
features can be
textual.
added to these also.
Okay, we can add those feature in this also.
Yeah, you can add that will be called as feature fusion with the CNN.
Oh, okay.
So that is a
So,
new paper also. That can be the new paper also.
oh, okay, sir. Okay, thank you, sir.
Yes, ma'am. So now I'm changing it to the input shape. And I'm adding the convolution 2 part also. So 28 by 28 by 1 image. After performing the convolution operation, it became 26 by 26 by 2. Sorry, here I want to use 64 filters. Yeah, 26 by 26 by 64. After applying max pooling, 13 by 13 by 64. Fine. Then con 2 has to happen, right? Pool 1, con 2. Why con 2 is not getting working? It's not working here. Yeah, pool 1 has been given it to this one. Activation equal to ReLU. Everything is fine. Con 2 is there. Anyways, it has to show con 2 also. I don't know why it is not showing. I think I have done some mistake. No mistake has been done.
Sir, in NN input, the input should be pool 2, sir. It's pool 1.
It's pool 1 only, right? Oh, sorry. Thank you. Thank you so much. Yeah. So 28 by 28 by 1. So it is divided, it is converted to 26 by 26 by 64. Then pool 1, 13 by 13 by 64. Convert to 11 11 by 16. Then finally the image is 5 by 5 by 16. So initially 640 parameters and they have been converted into 400 parameters. Fine, I had given it to the dense one, 400 by 64. That is 25,600. 64 bias values, that is 25,664 values here. And 10, the total number of parameters considered here is 36,186 random values. Got it? So fine. This is about the building a model. Now you can fit the model. The fit model code is available here. It will be run for some time. You can see the PDF now. I'll run the PDF now quickly because the time is up. 1 or 2 minutes. Yeah. Yeah, you can see here the fit model. So loss equal to the type of losses that I used. The loss values have been stored here using cross entropy technique. Optimizer that I have used is RMS prop. So then model checkpoint is not required. So model.compile checkpoint I didn't use here. Anyways, model.compile loss equal to loss, optimizer equal to optimizer, metrics equal to accuracy. That means accuracy has been measured. Model.fit of X-train with Y-train. Batch size 64 batches. 64 images has been considered as one batch. The number of epochs that I considered is 10 epochs. Validation split is equivalent to 0.2. That means 20% of the data will be considered as validation. That means out of 60,000 images, 20% is nothing but how many images? 1200 images have been considered for validation. So fit model, history is equal to fit model. The model is M that we have created with X train and Y train and 10 epochs. After performing the 10 epochs, initially the loss is 0.6. It has been reduced to 0.0. Initially the accuracy is 95% and it has been increased to 1. Then what I had done, I had given some random test values. M dot predict of X test. So then it has predicted the classes into one of those images, that means relevant classes. The these are the predicted values. These predicted values are compared with the true values, true test values, y test and y hat. I had drawn the confusion matrix like this. So the accuracy that I got, the confusion matrix later I have converted into heat map by using Seaborn package. This is heatborn. So the accuracy that I got with this approach is how much? The sum of diagonal values divided by total number of values. So I didn't print the accuracy here. I have printed the values of precision and recall. So precision is 0.982 and recall is 0.982. So this code, once if you experiment, then you will be confident with CNN. You can build your own models. Likewise, we have a lot of architectures, AlphaGo architecture, or we have GoogleNet, AlexNet, and Inception V3, ResNet, VGG16. So various and vendors have provided various architectures. You can experiment with all those architectures if you want, but their hyperparameters will be fixed. So this is what about CNN. I thought of covering medical imaging also, but anyways, I wanted to explain in detail about this particular. So Bane sir,
Yeah.
now the quote is yours.
Yes. Thank you very much, sir. So I think it is a very detailed explanation, and I think everyone has got what exactly the CNN needs, because the way that you have explained, it is very good explanation. I think again, your passion of teaching we are experiencing here. So thanks a lot for giving a detailed explanation with animation, with so many things, with handwritten things, and exactly the code explanation. So
All we have learned together, sir, during our NIT days.
yeah, nicely explained, sir.
Thank
So
you so
thanks,
much.
thank you very much. I hope everybody
Thanks to
likes
my
your.
supervisor for making me to learn to this level
Yeah.
at the end, and thanks to Baneraman sir for inviting me for giving a talk on for 2 sessions. So it's really thank you so much, and
Yeah.
thanks to the management of Yashwantrao Onsale Institute of Technology Management for giving this opportunity in the AICTI ATAL Academy to give a lecture on in the part of AICTI ATAL. So can I get 1 or 2 oral feedbacks so that I will wind up the session?
Yeah, please. Actually, they are writing in the chat
And
box.
thanks to the audience. Thank you so much for the response and for the patient listening.
Oral feedbacks.
1 or 2.
You're writing in the message box, but somebody
So
can.
it was really very good session. Actually, in this session, I'm teaching deep learning, so it will be really helpful for me.
Thank you so much, ma'am. Thank you, Ram sir.
Hello, sir.
Pratik sir, tell me.
No, I personally like the way you explained the implementation part, because
Thank you, sir.
generally whenever I listen to any CNN related thing, then it becomes more and more complicated. But your way of explanation was really good.
Thank you
Thank you,
so
sir.
much, sir. Sir,
Yeah.
fine, sir. Thank you.
Yeah. So I will copy the chat session and I will send it to you, sir, because so many.
Thank
good
you so
visitors.
much.
Yeah.
Thank you.
So we'll stop here. Manoj sir,
Yes, sir.
you stop the recording now, so that
Yeah.
the recordings will be divided into 2 sessions. And
Yes, sir.
we'll take a break of 1 minute and we'll start again.
Okay, sir. Okay. Thank you.
Immediately we'll start. Just for our purpose, you stop the video and then we'll start.